Hello. So this is the computer vision prototype now. I have made an alternative model for this section using PyTorch. I will not be discussing the comparison within this video. That will come in a later video because I do not want to be too repetitive, and sadly there won't be a lot to cover in the other video otherwise. So what is this? This is a fashion image classification system. So we want to think about retail. We want to think about how businesses are growing and growing. I'm going to take an example of an online clothing provider so that we can illustrate the kind of scale of this. We're taking ASOS, very large company. Other ones are available. You can see I've just gone in for a section, 500 items. If I go for view all shoes, God, you could have a shoe for every day of your life there. 1,464, and this is just one section, and particularly there are more women's clothes on these sites, so we can see the scale of this already. And not just that, let's think about the problem. In 2022, 7 billion was spent in returns. 7 billion. That's not good. That isn't good. These companies, how are they supposed to scale? The high street is no longer what it was. These companies, these high street companies, if you take Debenhams, if you take Next, these are now online businesses a lot of the time. Whilst they still may have stores, these are becoming online. They're selling other products. They're becoming these marketplaces so that they can adapt, so that they can still maintain in this economy where people would much rather order something online and then return it. So we can see how there is a problem. It costs a lot to send these items back. It costs a lot for these businesses, and they cannot be expected to scale and improve without some assistance. Think about all these marketplaces. If you take ASOS, they're not just selling their own products, they're selling other brands. They're selling other brands' shoes, clothes, shirts, jumpers. I'm sorry, my dog is barking in the background. I don't know whether that'll pick up. Live demos do not always go well. But what can we do? Through automation, we can improve. So if I have a system that can identify whether a t-shirt's a t-shirt or a pair of jeans a pair of jeans, I can then start to improve the metadata. I can start to have it automatically uploading these images. I can have these products that being fast fashion. We have to understand this is fast fashion. Trends are changing day after day. Social media is changing the way that people consume clothes. Previously people would buy a shirt and they'd have it for 7-8 years. Now these products, they're coming out every day. We've just seen 1,400 pairs of shoes. Who needs it? But there is a demand for this. We have to understand. So we have to meet that demand. So what can we do? The goal of this is to take an image and automatically classify it into one of 10 categories. So we want to think about these AI concepts. And what I'm going to do is I'm going to draw an image. I'm going to redraw an image because I've done this a few times now, sadly. So, I've started to draw. You can see these lines. Oh, you can't see the bottoms of them, but sorry. There we go. So you can see. Pair of jeans. Pair of jeans is developing. Got a belt. Oh, I'm not good at drawing. So you start off with these outlines. You can understand where the boundaries are, and then you get to get scale. You get to get texture and shape, and you understand these more detail about it. You can see it's a button, nice button, and then you can see how it's different to oh god, can I even draw a shoe? Yes, somewhat. See how it's different to a shoe? That's meant to be a shoe. So you see how these are different. What this model is something called a CNN, a convolutional neural network. And just like I showed you in that poorly drawn example, you start off, you're drawing, you've got these outlines. You're building, and then over time you start to process. And what a CNN does is it's really good for images because it takes these images, layers them. Starts off, it's got a simple layer. It'll just start to process the lower level content. It'll go, wow, that's an edge. I think that's a button. I think that's the side of a jean. I think that's the heel for a shoe. I think that's a t-shirt. And then it'll go, wow. Next layer. Oh, I'm looking at the shape of it. I'm looking at the material. I'm looking at the texture. I'm understanding what this is. Oh, I'm looking at the colours. I'm looking at the background. I'm trying to understand what's going on here. And over time, it will build up this knowledge, and it will do that. And we do this ourselves. We don't consciously do it, but when we look at something new, we start taking the sides and we take in more information. And this model, similar to people, Except what it does, instead of you and I looking at an image with our eyes and then we take that information into our brain, an AI model, a CNN, it will take these images, it will turn them into numbers, and then it will tell you what it is. So I just want you to understand, it's quite simple concepts. So what it does is we're going to talk through it step by step. So we start off with this data set of images. So this is 60,000 images that you use to test. And what it has to do is it has to flatten them, because you look at these are different sizes. How are you supposed to understand the difference between a shoe and a pair of jeans if they're different sizes? So it sets the playing field level, it evens everything out, and what you do is it normalizes them. So when they all look alike, it can start to identify those patterns. It's a lot simpler than your eye. It needs to have them similar to each other so that it can identify, and then after that it can start to build that understanding, and then it can go on to the more complex tasks. So building a model. So what it does, I said about these layers, it starts off just identifying small parts of the images, patterns, edges, lines, moves deeper through the model, it starts recognizing shapes, textures, and then over time it builds up an understanding of these 10 categories. Or I hope there's 10, I may have miscounted. And then what this is training. I've explained this in another video, but what an epoch is an AI. It's a bit like you learning something. You've got a set of flashcards. You've got these flashcards, you build upon them. So you've got a flashcard, and then what you do is you read it, and when you read it once, you don't know a lot. You're only 76% accurate, but then you'll look at them again, better and better, and over time you get really good. And then the risk is that over time, you're memorizing it instead of actually understanding what the patterns between the data is. So maybe slightly lost the rails there, slightly derailed for the analogy, but a model it's a very sensitive thing. It needs to go around a few times and understand stuff, and then after a point it will fall off because it will go so used to the data set. It's only 60,000 images, and you may think, wow, that's a lot of images. In terms of an AI model, it's not at all, and that's something I'll talk about in the improvements. You want to have more data. The more data, the more it understands, the more it can relate these patterns. Just showing you on ASOS, 1,400 and something pairs of shoes. There's far more clothes out there, far more clothes. So when it can get a larger data set, it can understand, it will be better at classifying all these images. So now that I've explained this, now that I've explained this, I can show you an example. So as you can see with this graph, it's learning, getting more accurate, and you can see the validation when it's being tested against. So, sorry, skip back. You see this? This is labeled data. So when I have my lovely image of my favorite shirt, this is my favorite shirt. When you have your favorite shirt, what happens is it will say, instead of being test 1, it will be t-shirt or shirt, and that's what we call like classification. It's labeled data. I apologize, I'm mixing these terms. Labeled data. So a training algorithm will train upon this labeled data, and it will get used to it. It will be told what's right and what's wrong, and then it can understand the connections between them. So it starts with this labeled data, and we can see when it's compared against this unlabeled data how it's doing very well. It's picking up the differences, and it's not failing as much. So here's an example I uploaded earlier. So you can see I've put a pair of trousers in here. I don't know whether do I have the image up? Oh, I have tigers and sharks, apparently. Did not expect that. This model does not identify tigers and sharks. I apologise for the curiosity. It's got this pair, and it's turned it to black and white because this is what the data set does. So that's the other thing. If we want metadata about colour and we want texture, it can be quite hard to identify. So we can build this model and we can improve it, and then we can scale it to other businesses. And not just that, this can be helpful for small business. I keep talking about ASOS, but this can be helpful for those high street stores, these smaller businesses. sky's the limit for this stuff. AI can be used for anything. We've seen recently, companies are pivoting from shoes to AI, and they're 500 timesing their stock. The AI has so many far-reaching possibilities. So I will just do another demo. So I'm uploading test image 1, and it saved it, and then we've got the shirt, and it's predicted that it's shirt. Now, we have just seen my favorite shirt. This is a t-shirt, and we all agree this. So look, it's 50% accurate, but it's 49% accurate that it's shirt. But we can see, it's hard to tell. There could be a collar there. It can be hard to dictate. So this model is not perfect. However, we can improve this. ASOS has so many different categories of clothing. This is such a narrow concept of the fashion now. You've got skirts, you've got other styles of shoes, you've got hats. Are there hats on here? No, got hats. So there are tons of other clothing items. I'm not an expert in fashion, that can be used. So we can see that it's not perfect, but we can see from the jeans 100% accuracy. It can identify these images, and I would say how often do we call a t-shirt a shirt? So perhaps this can be representative of an issue with the data set and our categorization, as opposed to an issue. Well, obviously the model does need some more training, so I won't weasel my way out of that one. But what we can see is that generally this model is being effective at recognizing these visual patterns. It performs well on the data set it's trained to, and we clean these images. It's not understanding the clothing. As we can see, it's calling the t-shirt a shirt, but it's recognizing these patterns that it's seen before, and we can improve this. So there's several benefits. It can automate a manual task. I upload the image, it tells me it's a shirt, and potentially with an improved model, you could say, oh, this is a shirt with a graphic design on it. It's a black shirt. It's 100% cotton. It's got hemming. It's got other features that I can't think to list, because unfortunately I am a sad little techie and I do not understand the fashion industry, but your clients will, and that's where we can help bridge the gap for. They can provide us data, they can provide us these clothes, and then we can build it, we can improve it, and we can cater this for all their needs. Improves consistency. The same logic is being applied to every image, and ASOS, let's say, will have 50 categories of clothing, and we can get a model to be trained across these 50 categories, and we can get more data, and we can get, just think, how many images must ASOS have of their clothing, of their partners' clothings, their partner organizations that they're selling on there. There must be so many images, tens of thousands, millions even. With a large enough data set, this can be improved. There can be more categories. It can classify. It can truly understand what is being in front of it. I apologize, I say truly understand. An AI model will not truly understand. I want to make this clear. It is recognizing patterns. It always will be recognizing patterns, but it can get more accurate at that. So you can see, even I'm slipping up in my language here. But not just that, it can improve customer experience. If I bought this shirt thinking it's a shirt and it came as a t-shirt, I'd be very upset. I'd send it back. So we can see how when this is improved, when it's acting like the jeans example, it can support other systems. It can support recommendation engines, accurate product categorization systems. However, like I said, limitations. Data set used. Images are very simple, low resolution, clean backgrounds, and it's very different from real world images. You just saw all the models are on there. It has to differentiate between the pictures of the shirts, the pictures of the items, and the pictures of the I apologize, my headset died. It's come back now. So, like I said, t-shirts and shirts can look very alike. It can lead to misclassification. We've seen this now. But what's important to remember is this is not the be-all and end-all. You can get more data. Like I've just shown you 1,000 pairs of shoes. Imagine if I had another 1,000 pairs of shoes on here. It can help identify the difference between a trainer, can identify the difference between a boot, a sneaker, an ankle boot, a sandal, all these things. It can get more granular and it can be used. And the model will struggle with complex images, despite this being a simple image, because it's flattened and because it's shrank down so that it can be interpreted. You can see it's hard to understand these lines. So not just that, it's limited to 10 categories. You know, when I'm buying clothes, I can't just have 10 categories. Not just that, I can't have 10 categories where 3 of them are shoes. What about my shirt? What about my skirts? What about my hats? What about my scarves? I'm in trouble. I can't buy the items I need. But real world systems and applications can use this, and despite the limitations of this model, it does not take away the fact that this is a strong proof of concept. We've shown that it's accurate, not all the time, but it is highly accurate. And not just that, we can see how e-commerce platforms can use it to improve search and filtering. If I go onto ASOS and I look at a graphic shirt and it's recognised that, an AI model has recognised that through the metadata, through the image, I can then be absolutely pummeled with more graphic shirts, and soon I'll be bankrupt because I'll have bought them all and I won't return any of them because it will be showing me the products I want in the size, in the style. And that's the thing, the aim of this is to improve the customer experience. As a customer, if ASOS is showing me the clothes I want, I will buy more. I won't send as many back. I'll think, wow, do you know what, this one's not that bad. I'll be shown products in the style I want, the size I want, the materials I want, and these are things that will impact a user, and it will prevent this this try after you've bought and send it back mentality. You cannot have this try before you buy without the high street. So in conclusion, this model, this CNN, this shows how AI can be used to analyze images and classify clothing items based on visual patterns. It shows strong performance in controlled conditions and highlights the potential for automation in retail. However, it shows that a real-world deployment would require more advanced data and a more advanced model, which I do have an alternative for, which will be explained in another video. Overall, this provides a solid foundation for understanding how AI can support image-based classification tasks. Because just think, even though I've given a fashion example, just think, what other images will your businesses, will your customers, will your clients want? What do they want categorized? You know, images are dealt with all the time. Will it be, you know, passports? Could it be passport data? Could it be recognizing whether the faces are in the right position, make sure that they're not smiling? Could it be, what could it be? So we've just got to think, images are used across all businesses, grabs people's attention, and a picture tells 1,000 words. How can we get those 1,000 words to be automated? How can we get this process to be streamlined, to take the focus away from this manual upload, this very tedious process? How can we make businesses better? And this is a strong start, and as you can see, look, it's a very short model. It's a strong model, but it's a short model. So what does it do? It identifies these fashion images using this CNN, using this idea of these layers, this understanding, and then it can test it on untrained data. And then overall, it's built up this understanding of pattern recognition. Let's be clear, pattern recognition, and then it's done. So I will explain the alternative model in a later video. Thank you for listening.